back. In this class, we're going to talk about polyatomic ions. Now, previously we looked at ions of elements and how to write formulas involving them. Now, this is going to take it a little bit further, so it's really important before you begin this one that you are comfortable writing formulas of the simpler ionic compounds. Now, for this, a polyatomic ion, we're going to start with the name. That is an ion that has more than one element in it. The name poly means many and atomic is atoms. So essentially, a polyatomic ion is more than one element in the ion. Now, there's quite a few of them and we're going to learn them off, and I'll show you which ones are the most important. Now, before we get started, the name of the ionic compound actually tells you whether it's going to be one element as the negative ion or whether it's a polyatomic negative ion. Now here, previously we saw the name if the name ends in IDE, that's going to be your negative element. So common examples, I've got 4 on the board. Chloride, so I see chlorine and it ends in an IDE, telling me it's negative chlorine. So the formula for this will be Cl-. That's a chlorine atom that has gained an electron to form a chloride ion. Now, sulfide, this is sulfur for sulf, and then it ends in IDE, so it's sulfur that has gained electrons. Sulfur is in group 6, it needs 2 electrons for a stable outer octet, so it will gain 2 electrons. The charge on the sulfide ion is going to be S-2 or 2- if you prefer, it's the same thing. Now, nitride, this is nitrogen and it's negatively charged. So IDE, we know it's negative. So we have nitrogen. Nitrogen is in group 5, which means it needs 3 electrons for a stable outer octet. It will gain 3. This will be N-3 or 3-. Now, oxide is possibly the most important of the ones that you'll come across because you're going to see it a lot. Oxides and the halogen, so chloride, bromide, iodide, whatever else. Okay, so this is oxygen with a negative charge. Now, oxygen is in group 6, the same as sulfur. So it will gain 2 electrons to become O-2. Now, they are all the negative elements. IDE, it's telling us we're looking at an element with a negative charge. Now, over on the other side of the board, there's another ending to the name of compounds where if you see it, it's kind of a dead giveaway that you're dealing with more than one element. If you see ATE at the end of the name of a compound, that signifies that you have oxygen in the formula. So examples are, I've put 4 on the board. We have carbon 8. The ATE tells me there's oxygen and the carbon tells me there's carbon as well. So there's actually 2 elements in this, carbon and oxygen. The formula for a carbonate ion is CO3 - 2 or 2-. Now for that, you can't figure it out based on the name or the groups. You actually just have to know what the formula of a carbonate ion is. Sulfate, so ATE at the end means we have oxygen and the first part is sulfur. So it's sulfur plus oxygen. A sulfate is SO4 - 2. Nitrate is nitrogen and oxygen, which is NO3-. Now permanganate, this one, don't go looking up the periodic table for an element called per. It doesn't exist. So here, that's actually it's one of the naming conventions we have for this manganese. So it's manganese with oxygen, and it's MnO4. You might also see, it's MnO4-. You might also see the permanganate ion written as the manganate 7, because it's the oxidation state of the manganese. Now, we're not going to worry about that now. We're going to call it permanganate for now because you've probably come across it as potassium permanganate. Right, so there's the naming conventions. There is another one that involves oxygen. You will only see one of them, and that's ITE. So get in the habit of reading the end of the name, and that will tell you whether you're dealing with just the negative element or a polyatomic that you have to know the formula for. Right, so I'm going to switch to my other board now and we're going to have a look at some common examples of polyatomic ions. Now, here, I know I said previously, we don't learn off formulas. It's a waste of time. You don't want to be driving yourself nuts in chemistry. Chemistry is hard enough as it is without learning off formulas. That is true because you'd be learning off hundreds and hundreds of different combinations of formulas, and we don't want to be doing that. We want you to arrive at a situation where if you know the process of writing the molecular formula, that it's going to work for everything. So if you could do it before for the simpler or more basic examples, you're now going to be able to do it here because the steps are the same. So if you can write the formula for sodium chloride, there's no reason why you can't do it for potassium chloride, vanadium chloride, beryllium chloride. So we're going to look at the steps involved here. But I will say this, for the polyatomic ions, you have to learn them because you can't be sitting in the exam going, what's the formula for a carbonate? Let's see if we can use the periodic table to figure it out, because you actually can't. It's not like the previous examples where you could use the groups from the periodic table to figure out the charge and the formula. These ones you're just going to have to know. Now, how I would approach this, treat them like your definitions. Now, I'll come back to it when I have them written out on the board, but we're going to treat them like definitions. So a list of our polyatomic ions. Now, they are grouped into different charges according to your notes. So we're going to start with the -1s first. My first polyatomic ion is a hydroxide ion. Now, this one is really important, and you're going to see this a lot across the course because we use hydroxides a lot, particularly in the acid-base chemistry and in a couple of the titrations. So hydroxide, hydrogen, and oxide for oxygen. Now, I know oxide would mean negative oxygen. It technically is, but the high is hydrogen. Now, before anybody goes, well, why isn't it ending in ATE? Because there's no such thing as ox8, because the oxide part is telling you the same information as ATE. And we don't call it hydrate because hydrate means water. There's all these lovely naming conventions in chemistry. We'll get there in the end. So we have OH minus. Now you can write the formula for that as minus or -1. By having the minus sign up there, that implies that there is a 1 beside it. So you don't need to write in the 1. Right, the next one in my notes, I'm going to put them in order, is a nitrate. Now we saw the nitrate on the other board is NO3 minus. The next one is hydrogen carbonate. Now this one is a little bit tricky. It has 3 elements in it. Now try and figure it out from the name. You have hydrogen, that's number 1. You have carbon, that's number 2. And it ends in ATE, so it has to have oxygen as well. So the formula for your hydrogen carbonate is HCO3, and it has a charge of -1. The next one is permanganate. Now this you won't see a lot in 5th year unless you are unfortunate enough to do the redox titrations in 5th year, which I think is a little bit mean, but here we go. So permanganate, this is MnO4 minus. Next up, now we're moving into the -2s. Now before we get there, I'm going to write the charge beside all of these. All 4 of these ions have a -1 charge, so they're -1 ions. Now, from those 4, it depends whether you're in 5th or 6th year, which one I will tell you to focus on. 6th year, unfortunately, you need to know all of them in this table. Chromate and dichromate, we'll let you away with that, but the rest of them, yes, you need to know them. So here, if you're in 5th year, I want you to put a star beside certain ones, because I tell my own 5th years that if they know 6 of these, you'll be fine. You'll ace 5th year. 6th year, you need all of them. So the most important would be hydroxide, nitrate, and hydrogen carbonate. So there's 3 of my 6 that I want you to learn off straight away. Now, next, let's look at the -2s. So I have carbonate is up first. So it ends in ATE. We know it's going to have oxygen and it has carbon in it. So this is CO3 -2. Now, one of the most common mistakes with formulas here is students mixing up the hydrogen carbonate with the carbonate. It's actually not the atoms itself, it's actually the charge. So you need to be careful here. Hydrogen carbonate has a -1 charge, but the carbonate has -2. It's because the carbonate has lost the proton or the hydrogen here, and its electron stays behind. So it has to be CO3 minus 2. Now, we'll look at that a little bit later about writing the formula of the conjugate bases. Don't worry about it for now, but we'll explain why later that's minus 2 and not minus 1. Right, next up, I have chromate. Now, I've debated whether or not to take this out of my notes because we're not supposed to use chromium anymore in teaching labs. It's actually been banned because it's highly carcinogenic and is very toxic to students. So it tends not to be asked. Now, if you come across it, I'm going to give you the formula for it, but it wouldn't be one of the super important ones. Chromate is Cr for chromium, Ate for oxygen, 4, and it's a minus 2 or 2 minus. Now, there is another one. Did I do dichromate next? I did. Dichromate. Now, we're not going to be looking at the periodic table looking for an element called di. Di means 2. So we have 2 chromiums with oxygen. This will be Cr2O7 minus 2. Now, the 2 of those not super important. You should know them, so learn them, but put these on the end. I wouldn't learn these first. Now, after that, I'm pretty sure we went to sulfate. We did. We have sulfate. So sulfate is sulfur plus oxygen, which would be SO4 minus 2. And the next one is sulfite. Now, be careful of this one. Sulfite, the ITE also signifies oxygen. So if you have sulfur and oxygen, you have a different number of oxygens that can bond to the sulfur, but the charge will still be minus 2. Sulfate was taken for 4 oxygens, and sulfite is SO3 minus 2. Now, that's the difference between the two. ITE is also indicating oxygen in this case, but it's 3 of them. And for sulfate, the ATE, 4 oxygens here. Now, we're nearly there. We have thiosulfate. Okay, if you've done rates of reaction, you've definitely come across sodium thiosulfate because you use it in 2 of the experiments, and it's the one that makes the experiment smell like rotten eggs. It's vile. It will also come up in the redox titrations, the more difficult redox titrations, the one with all the color, the really loads of color changes compared to the other titrations. Now, a thio in chemistry indicates sulfur. Sulf is also sulfur, and 8 is oxygen. So with a thiosulfate, it actually has an extra sulfur, so it has 2. The formula for thiosulfate is S2O3 minus 2. Now, in regards to the titration, you will always be given the balanced equation, so you don't need to learn it off for that, or the rates of reaction experiment. But just in case you get a question, write the formula for sodium thiosulfate. You should know the formula for a thiosulfate ion. Now, we're nearly there. The last one, I'm pretty sure we're moving on to minus 3 now. We are. So these are all minus 2 ions. There is only one minus 3 ion on the course, and that's the phosphate ion. So phosphate, phosphorus plus oxygen, will be PO4 minus 3. Now, there is a couple of places where you'll come across phosphate ions. One of them is in acids and bases. You'll come across phosphoric acid. It's a triprotic acid. We'll see it later. Now, down the bottom, you have the only positive polyatomic ion on the Leave and Cert course. Try saying that 10 times. But it's the only positive one that you're going to come across, and it's the ammonium ion. Now, if you've been doing chemistry for a while, you've probably come across ammonia. The formula for ammonia is NH3. The ammonium ion is where it has an extra hydrogen. It has gained a proton because ammonia is a base. So here, the formula for this is going to be NH4 plus. So that's my +1 ion. Now, how you're going to tackle all of these, let's put in the other important ones first. So if you're in 5th year, you definitely need to know the 3 on the left-hand side. You also need a carbonate a sulfate, and a sulfite. They would be my 6 to focus on, particularly if you're in 5th year. 6th years, you need all of them. Leave chromate and dichromate until last. Right. The reason why you have to learn these specific ones is you're going to see them in various topics throughout the course. And it makes it easier to figure out what's going on if you know the formula, so that you're not just going, oh, potassium permanganate is doing this. I don't know what a potassium permanganate is. So it's going to help you figure out what's happening in the experiment or the reaction. Now, how I would approach this is treat them like a definition. So at the start of all of this, I recommend that you take one definition every night and you spend about 5 minutes on it, and that's it. So if we all can afford 5 minutes a night to look at one definition. So you start off with hydroxide. Now, how you learn off these is you're going to write it out. You can probably write it out about 50 times in 5 minutes, probably more. But when you do that, it becomes part of your muscle memory, so that when it comes to writing the formula of your hydroxide, you're going to remember what it is. So hydroxide, we learn that for 5 minutes and then you leave it alone. The next night, don't do another polyatomic. Intersperse other definitions in here. So you might want to go off and learn the definition for electronegativity. Then on the next night, so say for example, we started on Monday, we're now on Wednesday. Wednesday night, you start on the nitrate ion. You spend 5 minutes learning off the formula for that. Then the Thursday night, you pick something different, like what's a sigma bond, etc. So try and keep them separate. Don't learn them back to back, and keep them a little bit spaced out. That is actually to help you with the charges. It's really important you don't sit down for half an hour and try and learn all of them together, because I can guarantee you're going to mix up the charges. Specifically, when it comes to the -2s, you'll be going, is that -2 or is it -1 or what is it? So just be careful of that. Now, there's something that I want to mention before I move on, and it is actually to do with the naming of a couple of them. And I'm actually going to write them here. Now, this is something particularly 6th years, you probably saw this last year. 5th years, you're going to find this a little bit tricky at first. So there's 3 words I'm going to write here. I have sulfide, sulfate, and sulfite. Okay. Now, those 3 are not the same. Every single one of them contains sulfur. That's the sulf part of it. Now, how you would work out how to use these in the formula is the ending. So IDE, that's the negative element. So the formula for the sulfide is going to be S-2. Sulfate, ATE, is oxygen. So that is SO4 -2. And the sulfite, that is also oxygen, but it's not the same as this one. Sulfite will be SO3 -2. Now, it's important that you can distinguish between those, particularly IDE and ATE, because the examiner could ask you to write the formula for potassium sulfite, and a lot of people will actually mix up the ITE with the ATE, or they might think it's negative sulfur as IDE. So it is actually quite important that you can differentiate between them. Another example of this is nitride and nitrate. So IDE, the nitride, is N-3. Nitrate is NO3-. So just be careful with that. Make sure that when you're reading through this, highlight the ending and just take your time with it. Right, that's enough about that. So now we're going to dig into how we're going to use this. Now, there is a worked example in your notes underneath the table with the list of the polyatomic ions. However, I'm going to throw you in at the deep end and we're going to start working through some questions themselves. Now here, the most valuable thing you can do is, with a pen and paper, work through this with me, particularly if you were struggling with the idea of finding the lowest common multiple. By the end of this, you'll have it. Okay? So I'm going to move to the other board to do that. Okay, so let's look at the first 2 examples in the practice questions. Now, like before, I've put in 3 pages, 3 full A4 pages of practice questions on writing formulas. The answers are all at the end, so you can check them as you go. Now, for these, if you're a little bit hesitant, work with me for the first few. You can pause in between if you think you've got the knack and want to try it for yourself, and then push play again. Right, so we're going to start with sodium nitrate. Nice handy one to start off with. So, sodium is my metal. Now remember, metals will always lose electrons, so they will form the positive ion. The nitrate, that is my polyatomic, it's nitrogen plus oxygen. It's going to be the non-metal in this. Non-metals will gain electrons. That's why most of the polyatomics over there, apart from the ammonium, they are negatively charged. So this will form the negative ion. Right, so we write out our formulas. Sodium is Na. It's in group 1, so it has a +1 charge. Group 1 elements have 1 electron in the outer energy level. They lose 1 electron to get a stable outer octet. Nitrate is NO3 -1. Now you check your charges. You have a +1 and a -1. Add them together. +1 -1 is equal to 0. Remember, ionic compounds are neutral, so the positives and negatives, when they add together, there has to be the same number of them. So they'll add together to give you 0. Now, when that happens, you only need 1 of each when they add together to give you 0. Straight away. So my formula for sodium nitrate, remember when naming the metal comes first, you have sodium, which is capital N, small a, and then nitrate, capital N, capital O, 3 on the bottom, and that's it. Now, before anybody loses their mind going, do I need brackets here? No, we'll see that in the next one. With your polyatomic, when you only have 1 of them in the formula, so I only have 1 nitrate, you don't need brackets. 3 marks for your sodium nitrate. Now, number 2 is aluminium hydroxide. Now, this one is a little bit different. Aluminium is my metal, and that's going to lose electrons, meaning it forms the positive ion, and the hydroxide is the non-metal. Now, at this stage, if this is the first time you're really coming across polyatomic ions, I don't expect you to remember the formulas off the bat. You absolutely can use your table in your notes to work your way through questions like this. And to be honest, at the minute, all I care about is balancing charges. The rest of it will come with time, and you can go back once you've learned your formulas and try them again. So I'm going to keep this over here so that when I'm going through some of these ones, I can show you the formulas as we go and the charges rather than telling you to keep looking back in your notes. Right, so for this one, hydroxide is up here. So hydroxide is OH -1. Okay. And my aluminium is in group 3. So it will lose 3 electrons from the outer energy level to get a stable outer octet. And hydroxide is OH -1. Now look at your charges. You have a +3 and a -1. When you add those together, that does not equal to 0. So that means we're going to have to balance the charges. And this is where the lowest common multiple comes in. I need the lowest common multiple of the numbers in the charge. So that is 3 and 1. So now ask yourself, what's the lowest number that both 3 and 1 divide into evenly? It's 3. My lowest common multiple is 3. Now, divide the numbers from the charge into the lowest common multiple. So you have a 3 up here, and the lowest common multiple is 3. 3 into 3 goes once. That means you need 1 aluminium in the formula. For the hydroxide, you have a 1 in the charge. 1 into 3 goes 3 times. So I need 3 hydroxides. Now, this is where you need brackets. What I've just worked out is I need 3 hydroxides in the formula, so that's more than 1. When you have more than 1, you must put brackets around the full polyatomic ion. So the polyatomic here is the hydroxide, so put a bracket around the whole thing, and then you put the number outside on the bottom right, like that. So that's aluminium with 3 hydroxides. Aluminium needs to lose 3 electrons, but a hydroxide can only gain 1. So for every one aluminium, in order to get rid of its 3 electrons, there has to be 3 hydroxides and each one will take 1 electron. So now be careful here with your brackets. If you didn't put the bracket in and you put the 3 in there. Now, I know what you mean. You're trying to tell me that there's 3 hydroxides. However, as if a chemist is reading that, they'll start from the left. You have 1 aluminium, 1 oxygen, because there's a 1 here beside the oxygen, and 3 hydrogens. That's not the formula for aluminium hydroxide. When you have brackets around the hydroxide like that, that 3 multiplies everything in here by 3 to indicate that you also have 3 oxygens and you have 3 hydrogens. If I was to write this out, this would be Al plus 3. Then you would have OH minus, OH minus, and OH minus. And that's why if you didn't put the brackets in, your formula is not correct because you're missing 2 of the oxygens from the formula. Right. Now we're going to do a couple more like that. I'm going to move down and try and pick and choose some of the slightly trickier or nastier sounding ones. So let's have a look at number 4. Let's go for magnesium carbonate. Now, they do get trickier as you go down through them, but they're still based on the same principle. You figure out what your charges are. Do they add together to give you 0? And if they don't, then you do the lowest common multiple. And just remember, if you have more than 1 polyatomic, put your brackets in. Okay, magnesium carbonate. So here, you start off with your metal, which is the magnesium. Magnesium is in group 2 of the periodic table, and it's going to lose 2 electrons to form Mg plus 2. The carbonate is the non-metal. Now, the carbonate is something that a lot of students mix up the formula for. So if I switch over here, your carbonate is here. So it's CO3 minus 2. And this is where it's useful if you know what your formulas are so that you can just write them in and carry on. Okay, now look at your charges. You have a plus 2 and a minus 2. Plus 2, minus 2, they do add together to give you 0. So you're done. You only need 1 of each. My formula for magnesium carbonate would be MgCO3. Now, be very careful when you're writing the formula of the ionic compounds. You do not include the charges here when you are writing these formulas. The examiner will nitpick on that because if you write the charges in, you're actually giving the wrong formula. An ionic compound, this is the formula of the compound. It is overall neutral. So the examiner doesn't want to see any charges here. If a student is to write that as Mg plus 2, and then beside it, CO3 minus 2 like that, that is actually wrong. That is not the formula of the compound. So just be careful of that. Don't put your charges in when it wants the formula of the compound, because that's what the question is always going to be asking you for. Right, let's have a look at, let's go down. Number 8, sodium thiosulfate. Now, I mentioned it earlier where you're going to see this. You'll see it in rates of reaction and the redox titrations. Now, for those, you will be given the formula of sodium thiosulfate because it's always given in the balanced equation for the reaction. But it's handy if you can figure out the formula as well. So this is number 8. Now, if you're happy enough with these and you want to try some for yourself, absolutely pause the video and try a few more of them. You have 3 A4 pages, so knock yourself out. I have sodium thiosulfate. Okay. Sodium is my metal. And my thiosulfate is the non-metal. Sodium is in group 1. So it will have a +1 charge. Remember, everything in group 1 is +1. Apart from hydrogen, that one's a little bit iffy. Thiosulfate, it depends what the hydrogen is bonded to. A thiosulfate, now this one is one of the trickier ones. Thiosulfate is over here. That is S2O3 minus 2. Now just be careful of your formula with that one. So I have S2O3 minus 2. I have a +1 and a -2. Add them together. +1 minus 2 does not equal to 0, so we need to find the lowest common multiple here. Lowest common multiple of the numbers in the charge, I have a 1 and a 2. The lowest number that both 1 and 2 divide evenly into is 2. So, for sodium, you need to find out how many times does the number from the charge go into the lowest common multiple. So 1 into 2 goes twice. That means we will have 2 sodiums in the formula. And for the thiosulfate, 2 into 2 goes once. So you have 2 sodiums, but 1 thiosulfate. Now here, you don't need brackets because you only have 1 thiosulfate. You won't need brackets in this one. But you do have 2 sodiums. Now before I get loads of emails, why are we not putting brackets around the sodium? Because you don't need to. Sodium is one element on its own. When it is a single element, you don't need brackets. So for Na2, there's no brackets needed there. But for polyatomics, because you would have 2 elements together, if there was more than one of them, yes, you do need brackets around it. Okay, next. Let's have a look at some of the nasties. So let's go down. If we have a look at calcium, no, we'll do ammonium nitrate. We're going to do 13 and 14 next. Okay, now for these two, how likely is it you're going to be asked the ammonium ion in the exam? It's rare. However, it's a useful skill to have. So number 13, we're asked for ammonium nitrate. Now, if I'm feeling particularly annoyed with my 6th years, I'm going to give them a test, and I'm going to give them rotten ones like ammonium phosphate and see how they get on with that or something like that. So it is rare on the exam, but this skill that you're using here can be applied to loads of different compounds, regardless of whether or not you'll see them on the exam. It's the skill that the examiner is testing, not the compound. So we have ammonium nitrate. Now, ammonium, that is actually a polyatomic ion. Now, in this case, it's not a metal. Ammonium is not a metal, but it is going to be the positive ion. And nitrate is the negative ion. Okay, now they're both polyatomics. Ammonium, the formula for the ammonium ion is NH4+. And a nitrate ion is NO3-. You have +1 minus 1 is equal to 0. So you need one of each in the formula. Now when you're writing the formula, the positive one comes first. So it's NH4, and then you have your NO3 written after it like that. You don't need brackets here because you only have one of each of your polyatomic ions, so no brackets are needed. Now, the last one I want to have a look at is number 14, which is calcium phosphate. Now, this one, be very careful of your charges here. Calcium is my metal. Therefore, that's going to be my positive ion. The phosphate is the non-metal part, and it's going to be my negative ion. Calcium is Ca. Calcium is found in group 2 of the periodic table, and remember your group 2 elements will have a +2 charge because they will lose 2 electrons. Now the phosphate is PO4 minus 3. It's one of the bigger ones. Now check your charges. You have a +2 and a -3. +2 minus 3 does not equal 0, so we need the lowest common multiple of the charges. I have a 2 and a 3. The lowest number that 2 and 3 divide evenly into is 6. So my lowest common multiple is 6. Now here, 2 goes into 6 3 times. That means I need 3 calciums. The 3 from the phosphate goes into 6 twice. So you will need 2 phosphates. Now, because you have more than 1, you need brackets here. So we put right in your PO4, all of that, that's the polyatomic. You put brackets around it, and then you put the 2 on the outside. That means that will multiply everything inside the brackets by 2. Now, if we're a little bit like, oh my God, why is there so many of each? It's very similar to when you were writing the formula of aluminium oxide. Calcium will get rid of 2 electrons, but phosphorus needs 3. So just getting rid of 2 electrons from one calcium is not enough for the phosphate. So it actually needs more. So you keep going till everything has a stable outer octet. Now, luckily for you, you're not going to have to show the dot and cross diagrams for this, thankfully, because that would be an absolute nightmare. But if you can do that, where you're just getting the lowest common multiple and dividing the charge into it, that's going to give you what your number of atoms of each element actually is. Now, just to kind of prove it, calcium has 2 electrons, and I'm just going to write the phosphate over here. The phosphate wants 3, but the calcium can only give 2 to the phosphate. The phosphate needs another one. This calcium has a stable outer octet, so we leave it alone. We keep going. We put in another calcium. It will transfer 1 electron to that phosphate. Now the phosphate has a stable outer octet, we leave it alone. But calcium doesn't. It still needs to get rid of another electron here. So we need another phosphate. It transfers 1 electron to that phosphate. The second calcium now has a stable outer octet, so we leave it alone, but the phosphate doesn't. So you need a third calcium, and it will transfer both of its electrons to that phosphate like that. Now, you will never have to draw that diagram or anything like it. As long as you can figure out the number of atoms of each substance, you're absolutely fine with this. And being able to write formulas like this is worth 3 marks on the exam. It's typically found in the short questions, which is question 4, where you will be asked to write 2 of them. Now, I strongly recommend that you go through the next couple of pages and practice as many that you can get your hands on. And the answers are all at the bottom of page 108 for you to check.